You want to find the inverse Laplace transform of 3 over s squared plus 3s minus 4. In order to do this, we have to factor out the denominator. S squared plus 3s minus 4 is just s plus 4 times s minus 1. And to get this into separate fractions, we must use a partial fraction decomposition. So that's going to be a over s plus 4 plus b over s minus 1. Our goal is to solve for a and b, so we're going to multiply both sides by s plus 4 times s minus 1. So on the left side, the denominator cancels, and on the right side, we have a times the quantity s minus 1 plus b times the quantity s plus 4. I chose to multiply out the a. You have as minus a plus bs plus 4b. I then factored out the s. That gives us a plus b, and then the rest was negative a plus 4b. And so I just compared it. Here there's no s. It's 0s. So 0 has to be a plus b, and then 3 has to be negative a plus 4b. So you can do that if you want. The other way to do it is to plug in values. So you plug in s equals 1 to get that 3 is equal to 5b. So b is 3 over 5. And you can plug in s equals negative 4 to get 3 is equal to negative 5a, which means a is negative 3/5. So either way, you get the same answer. So then you just plug in a and b in the partial fraction, and then we just use the formulas. So recall that both of these look of the form 1 over s minus a. We look at the first one, we have negative 3/5 as the constant up here. That could just go outside. And we have s plus 4. That means a has to be negative 4. So we have negative 3/5 times e to negative 4t power. Similarly with the next one, the 3/5 also comes on the front. And then here a is 1. So that's why we get 3/5 e to the t for the inverse Laplace transform. So putting it together, we just add these two. We have negative 3/5 e to the negative 4t plus 3/5 e to the t. And if you want, you can factor out a factor of 3/5, and then you get e to the t minus e to the negative 4t. And that's our final answer.